Hi viewers, this is Dr. Jana and you are watching video with me on advanced data structures. Especially we are dealing the sorting algorithms, and today we will be going for this heap sorting algorithm. So in this heap sorting algorithm, let me show you. Let us we have some keys like 120, 20, 15, 50, 10, 35, 18, 1, 80, 22, 5, 3, 38, 7, 28. No number is repeated. Now, how many keys are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 number of elements are there or keys are there. So using all these things, I have to go for the heap sorting. So first I will tell you what is this sorting. Sorting means some elements or some keys are not in proper order, either ascending or descending order. So we have to make it in a proper order, either ascending order or the descending order. Now here in this sorting algorithm, especially we are going for this binary tree or binary sorting. What we do, first of all, we should have some fundamentals about this that is we call it the heap sort. The heap sorting, what we do, we have to make it either a min heap or a max heap. Okay, there are two type of heap are there. First we have to convert it into either a min heap or max heap. If you are converting min heap, the entire heap will be min heap. If you are converting max heap, so what is min heap and what is max heap? See, the root, here the root is 120. If the root is maximum number and the parents who are there, they are also carrying the maximum keys, then in that case it will be max heap. Other cases, if the root is the lowest key and the lowest means that is the lowest number out of the all. Similarly, if the parents are lower than the children, the key value I am talking about, then it becomes the min heap. Okay. So in this program we are going for this min heap. Then how you do? First of all, let us make it a complete binary tree. You know the procedure. What is the complete binary tree? The numbers are there. Complete binary tree, it is from left to right and level to level. Remember this thing. It is from left to right. Left to right means, see, from top to bottom means it will be first this layer 120, then 20 and 15. So left to right 20. So first I put 120 the root, then left side it is 20, then the right side is 15, then coming to the left side it is 50, then the right side it is 10. You get it now? Then the left of this thing it is 35, then the left of this is 18. Okay, so this level completed, then this level, and it is starting from left to right. Then coming here, then the left is 1, the right is 80, then left is 22, then right is 5, like that 3, 38, 7 and 28. So these are the keys we arrange just in the complete binary tree. It's clear? So one another interesting you see here, total number of elements are or the keys are 15. Can you check how many keys are there in the leaf node? And the leaf node you calculate, it is 8. 2, 2, 4, 6, 8. It's clear? So 15 by 2, it is around n by 2 number of nodes are there in the heap nodes or the leaf node, whatever leaf node, whatever, not heap, leaf nodes, right? So now I can say the number of nodes in the leaf, it is exactly n by 2. Okay, then here if we have two ways of making this heap, so we can one by one insert and we can compare and we can then swap or whatever things are there, or we go for the heapifying. That means do all the things at a time. It's clear? So that is the in the first cases, if you do one by one, the complexity is order of n. The second case is order of n log n. So it is log n, actually it is log n, because n number of nodes are there, it will be n log n. So okay, so this is the worst case complexity. So we have to take the, so this is there, you understand this thing. Now if you see this one, now what next, what other condition we needed there. So we are not going to tamper anything in the leaf node. What is the leaf node? What are the keys in the leaf node? So 1, 80, 22, 5, 3, these are all the leaf nodes. They don't have any children. Okay, so we are not going to do anything with that one, that will be there. So if you see, 50% of the nodes are the leaf nodes here. Total is 15, and 15 by 2, 8. So 8 number of then you can see it will, when 50% of the nodes we are not, key value we are not tampering, we are not doing anything, then we can understand the complexity gradually reduced, drastically reduced. Clear? So this is the technique we are using it here. Then I will be doing something here. Now we have to set it. Where you set it? Because I told you that the bottom leaf node we are not going to touch anything. Okay, then just one level above, so on the right hand side, what is that value? It is 18. Okay, so in this 18 here you can see it is 18. I just show you it is 18. Now what are the nodes? Left child is 7 and right side is 28. So what is the lowest? If you want to go for the mean heap, then 7 and 18 there to be exchanged, right? So instead of 18 I make it 7, and here I make it 18. Is it clear? So now yeah, I make it delete and 18, right? So this is the first thing, it is done. Okay, so now I set this one is over. Then I have to set the next one, this one. So which one is the lowest one? So left is 3, right is 38. So lowest is 3. So I make it here, it is 3, and here I make it 35. You get it now? I make it 35. So this is over. Now I want to set this. Set means, what is the meaning of set here? The set means we have to go for this converting into mean heap, right? So here 10, 22 and 5. What is the minimum here? 5. So I want to change this 5 and 10. I want to interchange this. Okay, so this is 5 and this becomes 10 here. Okay, so this becomes 10 here, right? Then which one I have to set? Now I have to come here. While I come here, the left child is 1 and the right side, left child is 1 and right side is 50. So we want to change. So this will be 1, this will be 1, and this will be 50. This will be 50, right? So this will be 50. So now the first level, that means after the leaf node the first level is completed, second level is completed. Then what I have to do? I have to go to the this level, and here I have to go set this key A15. Okay, this node I have to set it. So if I go to set it, so for this 15, what are the child nodes? 3 and 7. What is the lowest? It is the 3 the lowest. Okay, so I make it 3 and I make it 15. Okay, I make it 15. Fine. Now is it clear? So by changing, does it make any difference here? No, it doesn't make any, because it is 15 is the lowest, 7 is the lowest, we don't have problem. Then what I do? I come to this 20 here. Okay, so coming to the 20 here, if I come here the 20, so the left child is 1 and the right child is 5. So minimum is the 1. So I make it 1 here and I make it 20. I make it 20. Okay, so back 20. Now so if you check the this one also, there is nothing affected. Then coming here, when I come here, then what I need to do? I have to set 120 here, this key. So if I want to set this one, so the left child is 1 and right child is 3. So these both are to be changed. So this will be 1 and this will be 120, 120, right? Now is it okay? So right side you don't have any problem, left side again you check it there. So if I check it here, So it is okay. If I check here, it is here, but when checking it here, if I want to set this 120, this out of 2 children, left child is 20 and right child is 5 is the minimum. Okay, so what I need to do, I put it 5 here and 120 here. So I put 5 and I put 120 here. I put 120 here, right? So now it clear. So now here it is not affected, but coming here it is affected. You can check it here, because 120. So if you want to make it min heap, then it will be 10, and it will be 120. It will be 120. Fine. Now you got it now. Now these are the things it is there. Now what you need to do, now you need to delete from the root. So by deleting one we can take it and we can keep it here, and automatically will be going on adjusting that one, right? So this will cover in the next video, but just I want to explain you that first lowest is the 1. So you remove this one, delete this one and keep it here 1. So okay, so delete that one and keep it here. I keep it as 1. It's clear. Now what will do, when I delete this one, then what will happen, this 3 will try to come up. So this how to delete and how to check again all this min heap, that will complete in our next video. Okay, till then goodbye. I hope you have now sound knowledge about how to create the heap tree, and what are the different type of heap tree, min heap and max heap. And in this, as I told you, that the first we have to make it the complete binary tree, and we know what is the number of keys will be there at the leaf node, and what will be the height will be n log n, height will be log n, height will be log of n. Okay, so that is one thing. And second thing is that here the important thing is that does it occupy more space? No, it does not occupy more space. What is the space it is allocated, the same space it utilizes. So there is no problem on that one. Same thing, suppose some numbers are repeated. Suppose this 10 appears 3 times, 10 10 10 or something like that it appears. In that case, so this first 10 should appear first, second will appear there. So does it come in the proper order? No, it does not come in the proper order. Okay, so these are the some of the cases, and based on this, the same tree will convert to a sorted one, heap sorting. So that we'll do it in our next video. Till then, goodbye. So if you like this video, please do share with your friends, and also don't forget to subscribe this channel. At the same time, also please take care of health. Have a good day. Bye.